Okay, so we're working on the intermediate field lattice. We know roughly what it has to look like from having an understanding of the subgroup lattice on the left, but we need to actually go in and compute what these fields are. So that's our task now. Um, we know some things from the fundamental theorem of Galois theory. We know, for example, that let me just do this row here. We know that the degree of, say, T dagger over Q is the index of T in G. So it's the order of G divided by the order of T. T had order, what was T? T was in the order 4 category, and G is order 8. So these guys in the middle here, these are quadratic extensions of Q. These are quadratic extensions of Q that live inside Q adjoin beta I. Now, I can think of 3 of those. So here are 3. Well, there's an I in there, right? So I have that. Beta is a 4th root of 2. So beta squared is the square root of 2. And then of course, we have the product. Okay, so we have Q adjoin I, Q adjoin I root 2, and Q adjoin root 2. Let's go in and let's see if we can determine which corresponds to which. Okay. So let's go up and let's look at our automorphisms. Okay, so let's see here. Which of these S through U fix I? Let's go up to what tau and sigma did. Tau fixes I, right? Tau of I is I. So it must be that the subgroup generated by tau also fixes I, because the generator fixes I. So it must be that Q adjoin I, this one is S dagger. I believe that, at least. Let's now look at the one that fixes root 2. So let's see here. Where are we? We are right. Here we go. Okay. So let's see. Sigma, let me put a thought bubble over here. Sigma of root 2 is root 2. Okay, so in order to fix root 2, we have to have a sigma. Does tau squared fix root 2? Let's see. Root 2 is like beta squared, right? So that's tau of beta squared. Tau sends beta to I beta, so that's I beta squared. So that's, okay, sorry, this scratch work's getting kind of long. That's tau of negative beta squared. So that's negative tau of beta squared. So that's negative I beta squared. So that's beta squared. So that's root 2. Okay, so tau squared fixes root 2. So both of these guys fix the square root of 2. So I would call that one, I believe this one is T dagger then. And that means this one has to be U dagger. You don't really have to think about it. Okay. So those are the quadratic extensions. We've now worked out this portion. All right. So now we need to work out this portion, the upper guys. Okay. So let's go in and do exactly that. Let's start with, I'm going to follow the book here. Let's start with C dagger right here. So let's go up and remind ourselves what C was. C is the subgroup generated by 1 and tau sigma. Okay, so let's work out C dagger. The rest of them are similar. Okay, so C again is the subgroup generated by tau sigma. And we want to compute the fixed field. So the fixed field of this group is, of course, just the fixed field of tau sigma. So we want to know, what does tau sigma fix? Well, let's write out a general element. If we take some x in Q adjoint beta I, then what? Well, x is going to look like some rational number plus some rational number beta plus some rational number beta squared plus some rational number beta cubed plus some rational number I plus some rational number I beta plus some rational number I beta squared plus some rational number I beta cubed. Of course, let's just clarify each of these are rational. All right, now we're going to apply tau sigma to it. And I'm not going to skip any steps here. We're going to go one by one. So we're first going to apply sigma, and then we're going to apply tau. Right? So sigma, again, was rotation by, or not rotation, it was reflection in the real axis, so it conjugates. So when we do that, this real part's fixed. And then the other portion is negated. Now what does tau do? Tau fixes the i's and sends beta to I beta. So I'm going to fix the rationals in the i's, and every beta I'm going to replace with an I beta. Minus A4I minus A5I I beta minus A6I I beta squared minus A7I I beta cubed. All right, let's work that out. A1 I beta, that's an I beta squared, so that's a minus A2 beta squared. That's a minus A3 I beta cubed. That's a minus A4I. That's a plus A5 beta. That's a plus A6 beta squared. And then I cubed will be a negative I, but there's another negative I. So it's going to be minus A7 beta cubed. All right, and let's put them in the order they were in previously. So A0, where's my beta? It's here on the A5, so we get A5 beta. And then minus 8, that's in the right spot. A2 beta squared is there. The beta cubed is over on the right. It's A7 beta cubed. All right, now we got to go to our i's. The minus A4I is still there. That's good. And then I beta has A1 on it now. And then I beta cubed has I beta squared, where's that one? Oh no. Oh shoot. There's an I here. I missed it. There's 3 i's here, and I thought there was only 2. Okay, so the I beta squared stays. Good. And then I beta cubed now is A3. Whew, okay, so take your time, pause, and make sure I got everything right. And now what we need to do is we need to say, hey, tau sigma of x needs to be fixed. So that should be an x. So now we're going to go in and we're going to compare coefficients. So the constants are the constants. So A0 is A0. A1 beta needs to be equal to A5. A2 beta squared needs to be equal to negative A2. A3 needs to be equal to negative A7. A4 needs to be equal to negative A4. A1 needs to be equal to A5. A6 needs to be equal to A6. And the last one is A7 needs to be equal to negative A3. Okay, so A0, there's no conditions, right? A6, there's no conditions. That's fine. A4 must be 0. A2 must be 0 because they're equal to their negatives. And so what does a general element of the fixed field look like? Well, A0, no conditions. A1, we're going to leave as A1, but whenever we see an A5, we can write an A1. A2 must be 0. A3, we're going to leave as A3 for the moment. A4 must be 0. Is there a mistake here? Hang on one second. All right, no, everything is fine. Okay, so A4 must be 0. A5, we're going to write as A1. So A1 I beta. A6 is fine. I beta squared. And then A7 we can write as minus A3. All right, so this is A0 plus A1. And then let's see, we have an A1 beta and we have an A1 I beta. So we can combine them. And then we have an A3 beta cubed and a minus A3 I beta cubed. So we can combine them. And then that leaves us I beta squared. Okay, so we have this. Now, let's see. The degree of the extension C dagger over G dagger, C dagger over Q, should be the order of G divided by the order of C. G had order 8, C had order 2. 8 divided by 2 is 4. What's the degree that we got? We got 1, 2, 3, 4. Okay, that matches up. And we can even rewrite this. So if you sit, I'm not going to do it, but if you sit here and you work out this element 1 plus I beta, and you square it, you're going to get something involving an I beta squared, roughly because 1 plus I squared is 2I. And then this guy, this last guy, is going to be related to the cube of that. I'm going to write it minus A3 over 2, 1 plus I beta cubed. Right? So that is 1 plus I beta is the primitive element to get the extension C dagger over Q. So C dagger is Q adjoin 1 plus I beta. And it's not too hard to see that that has order 4. Okay, great. So as you can tell, working out these fixed fields is kind of tedious. You'll have some more practice in class and on your homework. Similarly, A dagger is Q adjoin I root 2. B dagger is Q adjoin beta. B was the subgroup generated by conjugation. Beta is purely real, so that makes sense. D dagger is Q adjoin I beta. And E dagger is Q adjoin 1 minus I beta. All right, so let's go in and let's recreate our intermediate field lattice now with all of the intermediate fields figured out. So here's our subfield lattice. We have Q at the bottom, and then we have Q adjoin root 2, Q adjoin I, and Q adjoin I root 2. Okay, so Q adjoin root 2 had above it DB and A, so this has above it Q adjoin I beta. I beta squared is negative root 2, so this makes sense. Q adjoin beta, beta squared is root 2, so that makes sense. And then A, Q adjoin I root 2, that also makes sense, that it has I in it and the root 2. It has I root 2 in it, so that's good too. And then C dagger was 1 plus I beta. And then E dagger is 1 minus I beta. These were reflections in not the coordinate crosses, so the elements we're adding is slightly off. It looks off. And then above all of these, of course, is Q adjoin beta I. And so all of our work created this lattice of subfields.